Welcome to a lesson of exponential functions. The exponential function is a function in the form f of x equals a times b raised to the power of x, where a cannot equal 0, b must be greater than 0, and b cannot equal 1. If a was equal to 0 or b was equal to 1, we would have a constant function, not an exponential function. The value of a is called the initial value or starting value, which is the function value when the input x is equal to 0. The base b is called the growth factor or decay factor. Notice the variable x is in the exponent of b, so this is an exponential function. Let's tell you that since the x is in the exponent, we are going to call it an exponential function. Now let's look at some example of exponential functions. The first example, f of x is equal to 5 times 3 raised to the power of x. In this example, a equal to 5 and b equal to 3. Another example, f of x is equal to 4 raised to the power of x. In this example, a equal to 1 and b equal to 4. The third example, f of x is equal to 1 over 3 raised to the power of x. In this example, a equal to 1 and b equal to 1/3. Here b is a number less than 1. Here we have to note two cases depending on the value of b. The base b is greater than 1 and the base b is between 0 and 1. If the base b is greater than 1, the function represents exponential growth. As x increases, f of x also increases. If the base b is between 0 and 1, the function represents exponential decay. Here, as x increases, the function value decreases. Now let's try graphing exponential function. Here we are given f of x is equal to 2 to the x power. b is 2 now. Let's make table here. Let's take some x value here. Value that I'm going to pick for x are going to be -2, -1, 0, 1, and 2. I picked this because there are an even number of them on both sides of the y-axis, and I want to see what this graph is going to look like. So if I plug in -2 for x, I have f of -2 is equal to 2 to the -2 power. I can write this as 1 over 2 to the second power, which is equal to 1 over 4. So when my x value is -2, my y value is 1/4. Next, I plug in -1. f of -1 is equal to 2 to the -1st power. It's equal to 1/2. Next, I'm going to plug in 0. f of 0 is equal to 2 to the 0 power. Anything to the 0 power is just 1. So here we have f of f0 is equal to 1. Next, I plugged in a +1. f of 1 is equal to 2 to the first power. It is just 2. So my x value is 1 and my y value is 2. And then lastly, I'm going to plug in 2 for x. f of 2 is equal to 2 to the second power. 2 squared is 4, so my y value is 4. Let's graph this, and my graph will look something like that. Let's look at this graph a little bit closer. What happens to this graph? As we move along the x-axis in the negative direction, we are getting a fraction that getting smaller and smaller. So our y value is getting closer and closer to 0. It will never reach 0. This graph will never ever cross the x-axis. That makes the x-axis an asymptote. An asymptote is just the value on your function that your function cannot reach, but it gets closer and closer to. We can say that the asymptote is y equal 0. Now, as we move in the positive x direction, our function value or our y value also goes to infinity. As x gets very large, our y value gets very, very large. Because this happens, we would call this an exponential growth function. As x gets larger, our y grows. Our y gets very, very big. Let's talk about domain and range. So if I look at the domain of an exponential function, remember the domain is going to be the set of all x value that are going to make your function true. You can plug in any number you want between minus infinity and infinity. So the domain is all real numbers. Let's talk about the range. The range, remember, is the output. So whatever number you plug in for x, are you able to get any possible number? But I can't put 2 raised to some power and get a negative number. Also impossible for me to put a value into x and get the number 0. So our range doesn't include 0, so it gets from 0 to infinity. Y greater than 0, that's going to be the range. Second example about an exponential function. F of x is equal to 1/2 to the x power. Here the base a, number less than 1. So this is an example of an exponential decay function. This would be exponential decay. Let's make a table here. Let's take some x value here. Values that I'm going to pick for x are going to be -2, -1, 0, 1, and 2. So if I plug in -2 for x, I have f of -2 is equal to 1/2 to the -2 power. That's the same thing as 2 to the second power, which is equal to 4. So when my x value is -2, my y value is 4. Next, I plugged in -1. F of -1 is equal to 1/2 to the negative first power, or to the first power. Anything to the first power is just itself, so this is 2. Next, I am going to plug in 0. F of 0 is equal to 1/2 to the 0 power. Anything to the 0 power is just 1. So here we have f of 0 is equal to 1. Next, I plug in a positive 1. F of 1 is equal to 1/2 to the first power. It is just 1/2. So my x value is 1, my y value is 1/2. And then lastly, I'm going to plug in 2 for x. F of 2 is equal to 1/2 to the second power. 1/2 squared is 1/4. So my y value is 1/4. Let's graph this, and my graph will look something like that. Notice as we keep going in the positive direction, we are getting a fraction that getting smaller and smaller. So our y value is getting closer and closer to 0. It will never reach 0. That makes the x-axis an asymptote. Notice as x get larger, our y gets smaller and smaller. So we start from a large quantity and we decay very, very, very quickly. So this is an exponential decay function. The domain is all real numbers, and and the range y greater than 0, or all positive real number. Thank you for watching.